Okay, so welcome to this lesson where we want to look at ECZ, a GCE paper 2, 2018. Okay, so these are the first, this is question 1 and part of question 2 is here. Then the other part of question 2 I'm going to give you as we go on. This lesson we're going to solve the entire paper. Okay, it has got 12 questions. So we're going to have about 2 hours or so of doing this question paper in full. Okay, so please don't forget to share these things and to comment, even to subscribe. Okay, so now let us see what we are supposed to do to find the value of x. So given that A is given by this matrix, find the positive value of x for which the determinant of A is 12. So we have been given the determinant of A, of A matrix, yes? Then we need to find the value of what? Of x. So we are going to write an expression for the determinant, okay? Then equate it to 12. So what are we going to do? So the expression for the determinant, we multiply the 2 elements in the major diagonal, which will be 2x multiplied by x, okay? Minus 3 multiplied by 2, and this must be equated to 12. Okay, then what are we going to get? We're going to get 2x squared minus 6 is equals to 12. So we solve this as an equation. 2x squared is equals to 18. The additive inverse of this one is a plus, so it goes the other side. You add 6 to 12. Okay, so what are we going to get? So here, we divide both sides by 2. What do you get? X squared is equals to 9. Then x is equals to the square root of 9. So x is equals to 3. Remember, a root always produces 2 answers, a positive and a negative. But in this case, the question guided us to say we should find a what? A positive value. So the positive value is 3. That's what we're going to get. Then the second part is saying, find the what? Find the, hence or otherwise, write the inverse. This is an inverse of A. That is what that expression is talking about. So how do we write the inverse of A? So the inverse of a matrix, we find it by, so we're going to say, the inverse, the inverse of A is equal to 1 over the determinant multiplied by the adjoint of this matrix A. So 1 over, what is the determinant? The determinant is 12. How do we find the adjoint? Okay, now take note that here, since we have found that the value of x is 3, this is going to be 3 here, and this one you multiply. 2 multiplied by x, which will be 6. Okay, so to find the adjoint, these 2 elements in the major diagonal, they switch positions. So we're going to have 3, 6 here. Then these ones, you multiply them by a negative, or they change their signs. So you have minus 2, minus 3. Okay, this is what we are supposed to get. This is our determinant. This is our inverse. But if you want, you can go further and simplify this. This is going to be 3 over 12, negative 2 over 12, negative 3 over 12, 6 over 12. Okay, so when you simplify this, this will give you 1 over 4, the first one. This one will give you negative 1 over 6. This one here will give you negative 1 over 4. This one will give you 1 over 2. Okay, but even if you left it at this point, you won't be penalized. Okay, so basically this is what we are supposed to get for the first question. So the first question, we have done the whole lot of it. Solved everything under question. Question 1A, we have solved everything. So we come to question 1B. Okay? Question 1B. Question 1b. Solve the equation x squared minus 4x minus 2 is equals to 0. Okay? Okay, so we come to B. Solve the equation x squared minus 4x minus 2 is equals to 0. Giving your answer correct to 2 decimal places. So that's what we are supposed to do. So now, if you look at your question paper, there are formulas that are given, and this is a quadratic equation. So a quadratic equation where we cannot factorize using which we cannot solve using factorization method. So we need to use the quadratic formula, and the quadratic formula is what? Minus b plus minus b squared minus over 2a. This is our formula here. Okay? So now what we are supposed to do in this case is we need to identify. Okay? We need to identify our A, our B, and our C. We identify these ones. Okay? We identify these ones. So, our A is the coefficient of the letter that is squared here. So, in this case, the coefficient of x squared is 1. So, that is our A. Then our B is the coefficient of a letter that is not squared, which is negative 4. That is our B. Then our C is the constant, this number, which is minus 2. We are getting these. Okay? Our A is the coefficient here. Our B is the coefficient of x. Then C is the constant. Once we have this information, then we put it in the formula. That's all. Okay? So for this, for B, this is a negative, and here we have a negative on the formula. So because of this minus and this minus, we are going to have a positive 4. So we can say positive 4 plus or minus. Okay. You square negative 4 again here, minus 4 multiplied by A. What is our A? 1 multiplied by negative 1 divided by 2 multiplied by 1, which is our A. Okay. So now, at this point, what we are supposed to do just is to deal with the 4 plus minus. What do we get here? Here we are going to get 16 minus. What are we going to get here? This gives us what? This gives us negative 8 over 2. Okay? Then we proceed again from this point. This, remember here we are dealing with x. So we have 4 plus minus the square root of, these ones are going to be added, we get 24 here, over 2. Okay? Take note of where we are. So we come back here. We come back. So x is going to give us 2 values. X is going to give us 2 values. As you've seen here, we have 2 signs, a plus and a minus. So for the first one, we're going to get our calculator. You say 4 plus the square root of 4 plus the square root of 24 equals 4 plus the square root of equals then divided by 2. What you are going to get is x is equals to 4.45. This is going to be one value of x. Remember, we are told that you need to round off your answer to two decimal places. So these are 2 decimal places. Then we come back to another value of x. We have got two signs here. So the second one is going to be 4 minus the square root of 24 equals, okay? Then divided by 2. What do we get? I'm going to get negative 0.45. I'm going to get negative 0.45. So these are the answers that we're getting to this question. Okay, so let's go to question 2. Okay, so we look at question 2a. We look at question 2a now. Okay, look at question 2a. Okay, so question 2a, we are told to simplify this. In other words, we are multiplying the fraction, algebraic fractions. So what are we supposed to do here? So the easiest part that we're supposed to do here, we can come with, then we say multiplied by another one here. Okay. So for we look at, is there anything that is common here? We do not have. Also this side, we do not seem to have. Then we can now count, cross check here. 5 here, it's 1. 5 here, it's 3, isn't it? Then u, this u is cubed, and this u is cubed. So it's like we have 1, 1. Then v, here we have 1v, isn't it? Then this, so here we remain with v. Okay. 7 here, 1. 7 here, 4. Okay. S here you remain with s squared. Are we together? Then for t, this t and this t, here you remain with t. Okay? Here you remain with t. Okay? Okay. So now at this point you can multiply, you multiply 1t is the same as t. So when you multiply t multiplied by 1, you get t over 3 multiplied by 4, you get 12 v and s squared. This is what you are going to get as your answer. This is what you are going to get as your answer. So let's go to 2b. Okay, let's go to 2b. Okay, so here is the question. You can copy this question. So question 2b, we are told that in a GP, the third term, okay, the third term is equal to what? 2 over 9. And then the fourth term is equal to 2 over 27. Okay. Then we are told we need to find what? The first term as well as the common ratio. So we need to come up with the equations that will help us find the first term as well as the common ratio. So what formula do we use to find the nth term of a GP? It's first term common ratio. This is the formula that we use to find the nth term of a GP. So now, since we have been told that the third term is equals to 2 over 9, then we can say the third term, which is AR2, is equals to 2 over 9. Where is this 2 coming from? We've said 3 minus 1. That is where this one has come from. Then the fourth term, the formula is going to be AR3 is equals to 2 over 27. Where is this 3 coming from? 4 minus 1. So this is the fourth term, and this is the third term. So what are we supposed to do now to find the value of A or R? We need to solve these two equations simultaneously. So we are going to divide the second equation by the first one. we're going to divide the second equation by the first one by doing this. This is divided by a r squared. We also divide this side, saying we divide this side. What am I dividing with? 2 over 9. Okay? That's what we're going to get. Then from this point now, we can simplify this side here. We'll just remain with the r. And this will be 2 over 7 multiplied by, because of division, so it will be 9 over 2. Okay? 9 over 2. So now we can say 2 here, it's 1, 1. 9 here, 1. 9 here, 3. So our R is 1 over 3. Our R is 1 over 3. So this is it, or 0.33 goes on like that. So this is it, our common ratio. R is the common ratio which we have found here. Now, having found R, which is the common ratio, we can use the value of R to find the first term. We can pick one of these two equations, this one or the other one that we. So now we can say A multiplied by 1 over 3 squared, which is this squared here, is equals to 2 over 9. Okay. Then when you expand this, 1 over 3 squared is going to give us 1 over 9a is equals to 2 over 9. Then from this point now, okay, from this point, now we need to get the reciprocal. What is the reciprocal? What is the multiplicative inverse of 1 over 9? What is the multiplicative inverse of 1 over 9? It is 9 over 1. It is 9 over 1. So we need to use that. Say 9 over 1, we multiply it both sides. Also here 9 over 1. So this is going to cancel everything here. 9 into 9. So we remain with 1a, which is the same as a. So a will end up being 2. Okay. A will end up being 2. So the value of a is 2. The value of r, we can pick 0.33. Okay. That is what we are supposed to get. Now, from this point, we have the other questions that we are supposed to find. The sum of the first 5 terms of the GP. Okay. The sum of the first 5 terms of a GP. So, how do we proceed? The sum of the first 5 terms of a GP. Okay. Now, take note here that the formula that we are supposed to use, because r is less than 1, the sum of the first, is the nth term is equals to a then 1 minus r or n over 1 minus r, where a is the first term, r is the common ratio. Okay. So now, what is our a? Our a is 2. Then we have 1 minus, what is our common ratio? 0.335. We want the sum of the first 5 terms. Okay? Over, then here we have 1 minus 0.33. Okay? So, from this point now, we can use our calculator to find the answer. We can use our calculators to find the answer. Okay? We'll be able to get the answer using our calculators. So, for the first one, here, we just punch it as it is on the calculator. Okay? We say 2, open brackets, 1 minus 0.33 to the power 5. Then close brackets. So this is going to give us 1,992 2 when you round it off. Okay? Then this other one, if you want, you can say 1 minus 0.33. This is going to give us 0.67. Then you divide now this one. What do we get here? 1.9922 divided by 0.67. We are going to get 2.97 when you round off to 3 significant figures. This is what we are going to get. When you round off to 3 significant figures, this is what we are going to get here. So we can proceed to the other part. Okay. Okay, then we look at the other part. Okay. The other part, which is the last part, sum to infinity. Okay. So here we have B, sum to infinity, 1, 1, Roman numeral. Sum to infinity, what is the formula? The formula is the first term divided by 1 minus. Okay. So what is our first term? Our first term is 2 divided by 1 minus. Okay. So this is going to give us 2 over 0. This is 7. Okay? Now, when we divide this, what are we getting? So we can try to divide. Have 2 divided by 0.67. Again, here we're going to get the sum to infinity is equals to 2.99 when we round off to 3 significant figures. Okay? That's what we're going to get. Okay? That's what we're going to get. So now, we need to go to and to look at question 3. We need to look at question 3. Okay? So copy this question. Copy this question. Okay? Copy the whole lot of question. Pause it and copy the question. Okay? Okay, so let's see what we're supposed to do here. I'm sure you have gotten the question. I'm sure you have copied the question. Okay? So, if you have copied the question reads, the diagram below shows how learners in a grade 12 class at Huayenda school travel to school. The learners use either buses, that is B, cars, that is C, or walk to school. So these are the modes of transport that they use going to school. Bus, cars, or they walk. So if 22 learners walk to school, if 22 learners walk going to school, find the value of what? X. 22. So meaning, what is in this set, which is those that were walking, going to school? They are 22. So what is this one? So we need to add these two and these three and subtract them from what? From 22. So in other words, we can say x plus 4 plus 3 plus 7 is equal to 22. Okay? Are we there? This is going to give us x plus 14 is equal to 22. X is equal to 22 minus 14. X is equal to 8. Okay? X is equal to 8. This is the question 3A. Roman numeral number 1. Then we have Roman numeral 2A. From this Venn diagram, how many learners use only one mode of transport? Only one mode of transport. So, Those that use only one mode of transport, how many are they? So these ones only use what? Okay. These ones only use buses. These ones only use cars. These ones, they only walk. So we need to add these three numbers. We're going to get 28. Okay? Then C or B. Those that use two different modes of transport. Two different modes of transport. So it means we need to add now. Okay? Two different modes of transport. That means we need to add this one and this one as well as this one. Okay? What are we going to get? So this is going to give us 9. This is going to give us 9. So 9 is our answer here. Okay? The value of x, so that is it. Then, question 3a, question 3b, I'll be able to write it on the board. Okay? The question says, show, that is 3b, show that the points L, negative, then we have M, 2, comma, N, that is 5, comma, 11. Show that these points are collinear. Show that these points are collinear, meaning they are lines that they are points that are lying on the same line. But one thing that I must emphasize here, there are two methods that we can use to demonstrate this. For I know, or there could be more. Okay, there could be more, but we can use, because collinearity is found in vectors as well as coordinate geometry. Okay, so we can even use coordinate geometry to prove that these. So, for instance, if we have these points, they are like this. Okay, L is here, M is here. Just an example. Then N is there. So what we are saying is that this gradient here, okay, this gradient should be equal to the gradient that we are going to get here, which is the gradient, for instance, 1. This should be equal also to this one, gradient 2, and it should also be equal to this one. Okay, so we can even use the gradients to prove this. But there is also vector method that we can use, of course, for the scalar and stuff like that. So we can use coordinate geometry method. Okay? So we can say the gradient, if the gradient, okay, if the gradient, if this M1 here, okay, if this M1 is equal to M2, okay, they are equal, then we can say they are 2. So we can say we are using this one here. So we can say M1 is equals to, you know, I'm sure that the formula that we use for the gradient is y2 minus y1 over x2 minus x1. So for the first one here, we are using the coordinates of L and the coordinates of M. So this is our y2, we can say 2 minus our, so this is a minus, okay, so we can have a plus here, over, again 2, this is a minus, so it can be a plus again. So this will be 12 over 4. This is going to give us 3. Okay, so the gradient here, the gradient of the line the gradient of this line is equal to, let's try the other one, and this I said is m1 is equal to 3. So let's try the other one, which is like m2, where we are saying this is now mn. So we're using the coordinates of n and m. So here y2 is equal to what? 11 minus y1, which is 2, over y2 is 5 minus, which is this is going to give us what? 9 over 3. What do we get? We get 3. So this one, so you've seen this gradient which we got here, the first one, is equal to this one. Okay, so hence we can use this to conclude that the 2 points are lying on the same line. The 3 points, I mean, the 3 points are lying on the same line. If you want, again, you can find the gradient of this point from here to be the same thing. But we can also use vectors to get the same, to come up with a conclusion that the 3 points are collinear, meaning they are on the same line. Okay, we can also use such a thing. So now I need to take you to question. I need to take you to question 4. And that is where we're going now. Please, if you haven't subscribed to this channel, I ask you to subscribe to the channel, give us some comments, and other ways on how best we can provide these lessons. So let's go to question 4, which is construction. Okay, let's go to question 4, which is construction. So we come to question 4, which is on construction. And question 4a reads, construct a triangle PQR in which PQ is 10 centimeters, QR is 8 centimeters, and the angle PQR is 50 degrees. Measure and write the length of PR. Okay, so let us start. Okay. So we need to have a sketch here. The sketch is P, Q, and R here. Okay, it's going to be, so I have to use a red pen. So PQ is equals to 10, QR is equals to 8 centimeters. Then the angle at Q, PQR, this angle here must be what? 50 degrees. Okay, then we are asked to come and measure this one. So that is what we are going to do. All right, can we do that? Okay, so we can start. The first one is supposed to be 10. Okay, 10 centimeters. So we are here. I'm sure you can see where our 10 is. So we're going to measure from this point 10 up to here. Okay, this one. Okay, that's good. Then from this point, now take note, this is our P and our Q is here. Then take note, our this angle here at Q must be 50. Okay, so can you see our 50? Our 50 is this point here. Now take note again that from Q up to R somewhere here should be what? 8 centimeters. So we need to get our ruler here and measure 8 centimeters. Okay, we need to get our ruler and measure 8 centimeters. This one, 8 centimeters up to here. Okay, so this is my 8 centimeters. So I'll come and measure 8 centimeters from here. Do this. Okay, then now I need to measure now to join from this point. It should be passing through this dot for the angle until it touches that arc. for the measurement, like this. Okay, so this is where our R is going to be. So we are told that this side we just have to join. So as we join, we should also like be measuring it. Okay, so we need to join this part here. We'll just join up to here. So this is like 7.678. So this is like 7.8. Remember, we are asked to measure this. Okay, so we have measured this one. That is what it is. Okay, or maybe if you want, we can say here A1 or A2, which is 7.8 centimeters. Now take note, we need to continue. We have questions that follow. Question B. On your diagram within triangle PQR, construct the locus of points which are equidistant from P and Q. Equidistant from P and Q. So P and Q, P and Q. So meaning we need to bisect this line. That is what that means. We need to bisect this line. So how do we bisect? We said this is supposed to be more than half. More than half. We do an arc here and another arc down here. I hope you're able to see. Then you change, you bring this side, an arc here, another arc there. I'm sure you've seen where they are meeting. There's this point and this one here. Then you join. You join them. Remember, the question says within the triangle, so it's supposed to be like this. Then continue outside, just like a guide. We may not really need it. So this is like B Roman numeral 1. Then we come to this other part. What does it say? Which equidistant from PR and PQ. So what is the common letter here? The common letter is P, so we need to bisect this angle P. Okay, and how do we bisect? You start with an arc here. Draw the arc like this. Okay, then you come here, you do this one, change it to this. Okay, so at this point where they are meeting, need to draw now this one within up to this point. So this can be B2. Then we come to 5 centimeters from R. 5 centimeters from R. So we get our ruler and measure 5 centimeters. Measure 5 centimeters, which is this one. This is our 5 centimeters here. So from R. So then you do this one. Okay. That is that. We go to the next question. A point T within triangle PQR is such that it is 5 centimeters from R. Take note, 5 centimeters from R, it's this arc here. And equidistant from P and Q. Label the point T. So it's talking about the equidistance from P and Q, it's this one. Okay. Then the 5 centimeters from R is this one. So where do they meet? They meet at this point. So this is the point where we need to put T. This point here. Okay. That's what we're supposed to do. Then we have another point X is such that it is less than or equal to 5 centimeters from R. Less than, so meaning from this point, it is on the other side as we go to what? To R. From here, we're talking about this other side. then nearer to Q than P. Nearer to Q than P, it's coming from this point, this locus here. When we constructed this one, this region that is this side is nearer to Q. This one which is this side is nearer to P. So this one which says nearer to Q, it means we are looking at this side here. Okay. And nearer to PQ than PR. So we are now using this one. Nearer to PQ. It means this side where we have PQ. Okay? This side where we have PQ. That is what we are talking about. So the region that we want here to shade, this is the region that is satisfied by all the three conditions. It is nearer this side, it's less than 5 centimeters. Okay, so this is the region that we are talking about. This is the region where our x must lie. Okay, so we can go on to the next question. Okay, so question 5. Question 5a is on probability, and the question reads: a box contains identical buttons of different colors. There are 20 black, 12 red, and 4 white buttons in the box. 2 buttons are picked at random, one after another, and not replaced in the box. Draw a tree diagram to show all the possible outcomes. The second one, what is the probability that both buttons are white? What is the probability that both buttons are white? Okay, so those are the 2 questions that we'll be handling here. So take note of the question. So when you read our question, we have 3 colors. Black, there are 20. Then red, there are 12. Then white, there are 4. Okay? So what is the total number? The total number is 36. So whatever we are picking, we'll be picking from. Now, because we are dealing with the 3 colors, take note, because we are dealing with 3 colors, so as we construct our tree diagram, it should have this kind of an arrangement. This is the 3 colors. Now, this is the first draw. Now, since 2 draws were made, we need to do another one here. Even here, we do the same thing. Even here, we do the same thing, like this. So we have black, red, and white, white, red, and black, white, red, and the black, white, red, and the black. Okay, so take note of this. Now, what is the probability that the first one to be picked to be black? It means here we are looking at how many blacks? There are 20, so 20 from 36. If the second one will be, if the first one to be picked is red, what is it going to be? To be 12 over 36, take note. Then this one, the last one will be 4 over 36. So if the first button that was picked is white, what is the probability that the second one will also be white? So this means that the total number of white buttons have reduced from 4 to 3. And also the total number of buttons in the box have reduced from 36 to 35. Okay? Then for these ones, those do not change, because what changed, what was picked at first is what? White. So for the red, they are still at 12, 35. Then for the black ones, they are still at 20, 35. Okay. Then take note, if the second one, if the first one that was picked
was ready. What is the probability that the second one will also be ready? What is the probability that the second one will also be ready? So this is going to be 11 over 35. Take note, 11 over 35. I can write it here, 11 over 35. Ignore this part, okay? This will be 11 over 35. So it means these other two colors, they are still intact, but the total number has reduced. This is still at 4 over 35. What about this one? What is the probability that the first one, if the first one that was picked was a black pattern, what is the probability that the second one will also be black? So this will be 19 over 35. Okay, then it means these two, they are still the same. These two, they are still the same, but the total number has reduced. Okay, so this is how the tree diagram is going to appear. This is how the tree diagram is going to appear, and this is what is expected of you to write as your answer for A, Roman numeral 1. Then what is the probability that both patterns are white? What is the probability that both patterns are white? So probability that you have white and white. So here what do we have for the first white? For the first white we have 4 over 36, and then the second one also to be white is 3 over 3 over what? 3 over 35. Okay, so if we simplify this one, for me I can say 4 here is 1. I mean 4 here 1, 4 here, how many times here 4? 9, isn't it? 4 here, how many times? 9. 3 here 1, 3 here 3. So we are going to have 1 over 3 multiplied by 35. So can we multiply now? What do we get? 1 over 3 multiplied by 5, we're getting 15, isn't it? Going to get 15, we carry 1, this and that, we get 9 plus that, get this one. So this is what is going to be our answer here. This is what is going to be our answer. So take note, we are done with question E. We are done with question 5A. We go to question 5B. Okay. So this is question 5B. Study the pseudocode below. Study, enter A, R, N. Capital R is equal to 1 minus R. If R is equal to 0, then print. Okay, go through this. Then the question says, construct a flowchart corresponding to the pseudocode above. So the flowchart is a diagram. Okay, so that will be corresponding to this one. So we shall be drawing it here. So a flowchart, it's all about the symbols. If you understand the symbols, I think that is the interest of the examiner. So here, if you check, what we have start. So we use this symbol for a starting. Okay. Our second one is what? We have enter. We use a parallelogram. Okay. What are we entering? We have to enter A, R, and N. Take note. Then the next one, what do we have? This is like a processor here. So this was processed here. So we use a rectangle. R is equal to 1 minus R. Then here we have a decision that has to be made. Okay. We used a diamond box. So we're going to say, is R equal to 0? This side we're going to say yes. Then here we're going to say no. Then, so this one goes with yes, the then part. So if this is the case here, okay, if this is the case, then we're going to say print, okay, print the value of R is not valid. Okay, this is what we're supposed to print. Then here where we have else, okay, else where now this one is not the case, we need to come to this one and we use the box. Say 1 minus r to the power n over r. Okay, that's what we're saying. Then the next part is what? What do we have here? We have print, isn't it? Where we use a program. So we say print, okay, and then from there, what do we have? Stop. This is what we are supposed to have. So this is what is supposed to be our answer here. Okay, so that's supposed to be our answer. So we go to question 6. Okay, so question 6 reads the diagram below shows a bin in the form of a frustum with square ends of sides 4 centimeters and 10 centimeters respectively. The height of the bin is 9 centimeters. Find the volume of the bin. Okay, so what are we supposed to do here? Okay, so we are going to keep our bin here. Okay, we're going to keep our bin here. Then the formula that we're going to use now here is the volume of a frustum is H3 area 1 plus area 2 plus the square root of area 1 and area 2. Okay, so what I'm going to do here, I'm going to find the values of course we know our height is what? Our height is given as 9. Okay, our height is given as 9 here. Then our area 1, okay, so this is a square here. We have 2 squares at the on top and at the bottom. So you know that the area for a square is L squared. So meaning if we are dealing with this one which is at the bottom, it will be 4 times 4. 4 times 4, which is going to be 16. Okay? Then the second one, so I'm calling this one 1. Then area 2 is going to give us what? Also 10 multiplied by 10. Going to give us 100. Okay? Then if you want now, what we can just do to make our work easier, maybe we can multiply them in advance. So this is going to give us, okay, when you multiply these 2, like for this part now, okay, what we are going to put here, area 1 multiplied by area 2, this is what we are going to get. Then after you have done this, you just bring these values now in the formula. Here we have what? 9, okay, 9 over 3, our area 1 is 16 plus our area 2 which is 100 plus here what do we get? 1. Remember we multiplied them in advance. So this is the same as what? What are we going to get here? This is going to give us 3. This one here you're getting 3. What do you get when you add this one? This is giving us this one. Then you can find the square root of this. Find the square root. You find the square root of what do you get? 40. 311 plus 40 here. Okay. So then plus 116. Then you multiply this by 3. So you add these 2 here. When you add these 2 and multiply by 3, you're going to get 468. Okay, centimeters cubed. We're dealing with the volume. This is what is going to be your answer here. Okay, this is what is going to be your answer. So we go to the next question. Question 7, that is. Okay, so we come to question 7a. In the diagram below, A and B are points on latitude 60 degrees north, while C and D are points on latitude 60 degrees south. Take pi as 3.142, the R as 3437. Not commas. Okay, we have the diagram here. Then the question says calculate the distance BC along the longitude. Okay, along the longitude, not commas. Okay, so from this point up to this point. So this is the distance that we want. So I'm sure you know we can use two formulas here. We can use two formulas, but maybe let's go for 2 points that are on the same. This is a general formula. Okay, this is a general formula here, where this one, theta is what? The distance, the difference in degrees between the 2 points. So this is our BC. So the difference here, which is our theta, when you look at this one, it's south, this one is north. So we need to add these two because they're in different hemispheres. So we're going to get 120 over 360 multiplied by 2 multiplied by 3.142, and 3 multiplied also by 3437. So let's punch this on our calculators and see what we're going to get. Okay, so this is going to give us 7199.39333. Okay, now when you round off to two significant figures, this will end up giving you okay, nautical miles. Now take note that we can also use a formula which is multiplied by 60. Okay, where when it's we are dealing with nautical miles, if you are using this one, and what is this? The same thing that we wrote here, which is 120 multiplied by this one will give you directly what? This one. So what you are going to get. So that is the answer for the first question. Let's go to the second one. Okay, so here we have a ship sails from C to D in 12 hours. Find its speed in knots. Find its speed in knots. So the first thing that we are supposed to do here is to find the distance. And what formula do we use to find the distance here? Okay, we can use the formula. Again, I said we can try to, okay, we can see how best we can do this. So these 2 points are on the same what? Latitude here. So we can say CD is equals to 360 multiplied by 2 multiplied by pi r, then cos cos what? Cos theta or cos x. So now this will mean that again here we need to find the difference in what? So this will give us what? 120. We have to add these two again. They'll give us 120 over 360 multiplied by 2 multiplied by 312 multiplied by 3437 multiplied by cos 60. Okay, the latitude here. Then we work this thing out on the calculator. Okay, we punch this on the calculator. 120 divided by 360 multiplied by 2 multiplied by 3.142 multiplied by 3437 multiplied by cos 60. What do we get? Okay, this is what we are going to get. We'll get 3599.684. Okay, so now this is our distance, isn't it? Take note, this is our distance. This is our distance here. So if we use this as distance, then we say distance divided by what? By time. Distance divided by time. But maybe first of all, what we can do is we can simplify this one. Okay, we can simplify this one, or we can rewrite this one correct to 3 significant figures. It will end up being this one, not commas. Okay, then take note that now to find the actual speed, we say speed is equals to distance over time. That's what we say, isn't it? So what is our distance here? Our distance is 30, isn't it, over 12. So you can divide this one, say divide over 12. Okay, so you see this is 3 divided by 12, so we're going to get 300. Okay, we're going to get 300 knots. We're going to get 300 knots. Okay, so this is what is going to be our answer here. Let's move on to part B. Part B says determine the equation of the normal to the curve. Okay, y is equals to 2x squared minus 3x minus 2 that passes through the point 3, 7. Okay, let's do this one. So the equation that we have is y is equals to 2x squared minus 3x minus 2. So we want the equation of the normal, and it should be passing through 3, okay. So the first thing that we're supposed to do here is to find the what? We need to find the gradient here. So we say dy dx. Please, I'm sure you should be familiar on how to differentiate this. We multiply by that, we get 4x minus 3 here. That is 4 minus 1, you get that. Then we want the actual gradient now. What is the actual gradient? So where there is x, we put what? 3, because that's the x coordinate. So this will be 12 minus 3. What do you get? Get 9. So this is like our m1, which is like the gradient of the tangent. Now we need the m2, which is the gradient of the normal. And m1 multiplied by m2 should give us -1. So this other one must be -1/9. So this is the gradient that we're going to use. Okay, so we'll be saying y minus y1 is equals to mx minus x1. Okay, then our coordinates, this is our x1, this is our y1, and our m is this one here. So we'll say y minus 7 is equals to, -1/9 x minus 3. So this is going to go on as we cross multiply. 9 comes this side, isn't it? Okay, 9 can come the other side here. 9 can come the other side. so that we can have 9y minus 7 is equals to negative 1x minus 3. Okay, that's what we're going to have, isn't it? Okay, so we say 9y minus 63 is equals to minus x plus 3. Okay, then we can rewrite this one. We can rewrite this one as 9y, this say plus x is equals to, here we have 3. Also this one, when it goes the other side, it will be plus 3. Okay, so this is going to be 66. This is what is going to be our equation. You can leave it at this point. You can leave it at this point. Sometimes others you would find it's going to be written as 9y is equals to negative x plus 66. Then they'll end up, this is one way it can be written. Another person will go further and divide throughout by y. Then you have y by 9, I mean. You have negative 1 over 9x plus over 9. Now you have negative 1. So here you can simplify this part. 3 here it's 2, 3 here it's 3. So just work with this part here. That will be okay. Okay, so we go to the other part, the other question. Question 7b2, evaluate. Okay, evaluate. I'm sure you've seen what we're supposed to evaluate here. Okay, so we are supposed to evaluate the integration of this one with these limits. So how do we do that? Okay, so this is what we are having 1, 0, x squared minus 2x minus 3. So we need to integrate this first. So how do we integrate? We're going to have x3 3 minus 2x2 over 2 minus 3x 1 here. Okay, I hope so. Now at this point we can simplify it further. I have x to the power 3 over 3 minus x squared. Because of this will give us 1 minus 3x 1 0 1 0. Okay, so then at this point we need first to slot in 1 everywhere where we have what, where we have x. Okay, then the second part we were supposed to say minus, we also do the 0. Now when we put 0 throughout, it will be 0 just. Okay, so let's do what I'm talking about. So the first one we're going to say what, 1 to the power 3 over 3 minus 1 squared minus 3 1. So this is what I was saying. When we do this, the second one we need to say minus. Again we use now 0. Where there's x we put 0 cubed over 1 minus 0 squared minus 3 0. So this is what I was saying, that this whole thing here will give us a 0. So we'll just concentrate on this part here. This is the part that we're going to concentrate on. Okay, this is the part that we're going to concentrate on. So this will give us 1 over 3 minus 1 minus 3. Okay, this can also, we can also further say this is the same as 1 over 3 minus 4. Okay, so now we are working out with this one. So we say what is common here. Say 3 is common. This here, it's 1. We say 1 multiplied by that will be that. Then 3, this will be 12. So we have negative 11 over 3. Okay, 11 over 3. Okay. So since the question is not telling us to say find the area, we can leave the question just here. I mean the answer, we leave it just at this point as negative 11 over 3. So this is the end of question 7. We need to go to question 8. So question 8 reads, question 8a. Villages A, B, and C are connected by straight paths as shown in the diagram below. Okay, so here is the diagram. Given that AB is 15 kilometers, the angle ABC is 79 degrees and the angle ACB is 40 degrees. Calculate the distance AC. Okay, so we need to find this distance here, isn't it? We need to find this distance here. So what rule are we going to use here? When you look at this one, we have this angle, we have the corresponding side. This one and the side that we are looking for is not given, but we have the angle. So this is sine rule. So here we need to use what? Sine rule. In this case, we can state the sine rule. This side that is opposite here, we can state the sine rule. It's represented by small letter b over sine b angle. Then we come to this other side. The second part should have both the angle and the side. So the side is C, then capital C. So this B, small letter b, is the side that is represented by AC. So we can say AC, okay, then over sine B. What is the angle here? 79 is equals to C. What is C? This is 15. Then sine 40 degrees. Okay, then remember we want this one, so we cross multiply. So it's AC multiplied by sine 40 is equals to sine 79 multiplied by 15. So you divide both sides by sine 40. So AC is equals to sine 79 multiplied by 15 over sine 40. So let's punch on our calculators and see what we're going to get. Okay, so when you punch this, this is the answer that you're going to get. The answer that you're going to get here. So once you can write it in full, AC is equals to 22.90711198. Then you round it off to 3 significant figures. You have 22.9 kilometers. Okay. So then we go to the next one, the area. The area. Okay. So the area here. Now this is what we are supposed to have, isn't it? And here we have found this one as what? 22.9. Okay, 22.9 here. Then they want us to find the area. So the angle that we can use here is this one, because we need these two sides and the angle that is in between them. So meaning, to find this angle, you need to add these two and subtract them from 180. What are you going to get? You will get 61. You can confirm that. Minus 79. Then minus 40. You're going to get 61. Okay? Then you use now the area is equals to half. Then multiplied by these two sides, 15 multiplied by 2.9, multiplied by sine of what? Sine 61. So we punch this on the calculator. Okay, so when we punch this on the calculator, this is what we're going to have. Okay, so we can round off these to 3 significant figures. What are we going to get? It will just be, okay, at this point, now this is kilometer squared. But if you, it's even best sometimes, maybe before you come to this one, you write it in full as it appears here. 2159347. Okay, let's move on to the other part. Okay, so we now look at the shortest distance from B to AC. The shortest distance from B to AC. So what formula do we use to find the shortest distance? Okay, so we have simplified it to use H is equals to 2A over B. A is the area and then B is the base. Okay, so look at what we got. You can look at what we got here. What was our area? Our area, we got 150 when you round it off. And our B, which is the base here, we got 22.9. Okay? It's even advisable to get those values that are not rounded off here. Okay? Then now we say 2 multiplied by 150. What do you get? Then this divided by 22.9. Okay? So what are you going to get? This is going to give you 13.1. So H, which is the shortest distance, is 13.1. 13.1. Okay, that's what you're supposed to get. So now we go to B. We come to B. B says solve the equation cos theta is equals to 0.937. That is for all the quadrants from 0 up to 360. So the first thing here that we're supposed to do is to find the first angle quadrant here, which we can call alpha. Okay? So how do we find this angle here? So we are going to say alpha is equals to the cos inverse of 0.937. Okay, so cos inverse 0.937. What are we getting? We're getting that the value of alpha is 20.4. The value of alpha is 20.4. Okay, so now we look at cos. So we are going to say, where is cos positive? That is where our theta is going to be. So cos is positive in the first quadrant. So the value of theta here in the first quadrant will be the same as the value of alpha. Then also cos is positive in the fourth quadrant here, in the fourth quadrant. And if this is our alpha, then this is also alpha here. So then in the fourth quadrant, it will mean that we need to find 360 minus 20.4. That is what is going to give us the value of what? Another value of theta, I mean. So this will be 339.6. So the values of theta are these two. These are the answers that we want. Okay? These are the answers that we want. Then we come to the last one on this part of question 8, which is the sketch the graph of y is equals to sine theta for 0 degrees less than or equal to theta less than or equal to 360 degrees. Okay. So what are we supposed to do here? So we come up with the can come up with the table first here. We're going to say x and the y. So this will start with 0 degrees, 90 degrees, 180 degrees, 270 degrees, and the 360 degrees. Okay. So then we start, we begin to find the values of what? Of y. Remember, what are we using? Y is equals to sine theta. So the values of theta here will be putting what? These ones that are here. So you can start with the first one. You say sine 0. This one will also be 0. Then you say sine 90. What are you getting? 1. Then you say sine 180. What are you getting? 0. Then you say sine 270. What are you getting? -1. Then you say sine 360. What are you getting? 0. Okay. Then you use now these ones. So you look at, for the x, what do we have? X, this is our x coordinate here. This is our x. So our x, we have 0, then 90, then 180, then 270, on the 360. Then for y, we have the highest here is +1, and also here it's -1. Then we can start plotting. We can start plotting this. Okay? So the first one is 0,0. The second one is 90,1, which will be here. Then 180,0 is this same point. 270, -1, it's here. 360,0, that's this point. Then you can join these points like this. So this is the graph that you are supposed to do. Okay? This is the graph that you are going to do. And now we can go to question 9. Okay? So we come to question 9. Answer the whole of this paper, of this question on a sheet of graph paper. A tailor at a certain market intends to make dresses and suits for sale. A. Let X represent the number of dresses and Y the number of suits. Write the inequalities which represent each of the following conditions below. Okay, so the number of dresses should not exceed. The number of dresses should not exceed. Okay, so this is question 9. Say question 9. Question 9. So A Roman numeral 1. The number of dresses should not exceed 50. So then X represents the number of dresses. So we're going to say X should not be more than 50. So should be less than or equal to 50. This is the first one. Then Roman numeral 2. the number of dresses which is x should not be less than the number of suits. Should not be less than, so should be greater than or equal to y. Okay, and for me, I like rewriting this part where I make y the subject of the formula, so it will be like y is less or equal to x. Okay, then the last part now we have the cost of making a dress. Okay, so this is 140x plus the cost of making a suit is 210y. The total cost should be at least. So at least is greater or equal to okay, write this as it is. So now you need to look for the highest number that can go into all these so that you simplify this equation. So if you divide throughout by 70, you divide this one by 70, this one by 70, the last one by 70. What are we going to get? Okay, what are we going to get? We can do that. This is going to be 2x plus, this is going to be 3y, then this part, say 10, 5 divided by 70. So this will be 150 here. Okay, so these are the inequalities that we have. 1, 2, and 3. Okay, we've done that part. Then we come to using a scale of 2 centimeters to represent 10 units on both axes. Draw x and y axis for x, it should go up to 60, for y up to 80. Shade the unwanted region to indicate clearly the region where x and y must lie. Okay, all right, so let's see C. Okay, so this is what we're going to have. This is what we're going to have for x, and for y we go up to 80. All right, so how we have the equations here, the inequalities. Of course, when we're dealing with them as equations, this one will be x is equals to 50. So where do we have 50? Along the x axis, it's this part here, isn't it? So we draw. Okay, now it's this in terms of an equation. This is x is equals to 50. Then we need to shade the unwanted region. So the less than is the region that we want. So you shade this part here. You shade this region here. You shade this region here, like this. Then you come to the second one, which is y is equal to what? In terms of an equation, y is equal to x. So y is equal to x, or x is equals to y. Okay, so if x is equals to 0 here, then y is equals to 0. If x is equals to 10, y is equals to 10. If x is equals to 40, then y is equals to 40. If x is equals to 50, then y is equals to 50. So we can draw a straight line here that passes through this point. This is the, I'm sure you know this special equation. It goes on like this. Okay, so in this case, I said we'll write it like this. Now we are considering the second one. Okay, so we are considering this one. So what is it saying? Y is equal to, y is less or equal to. So the less part is this one. So we need to shade the upper part here. Should be shading this upper part going up like that. Okay, shade it like this. Now take note, we have this one here. Okay, so also this one, in terms of an equation, it's 2x plus 3y is equals to 150. So we need to come up with a table of coordinates here, where we're going to say I'll work with I'm going to say if x is equals to 0 here, if x is equals to 0, okay, if x is equals to 0 here, then it means we're going to have 3y is equals to, so meaning you need to divide this one by 3, isn't it? You need to divide this one by 3. So it will mean this will be 50. Take note of that. Okay. Now we are going to say, what if y is equals to 0? What if y is equals to 0? Then x will be equals to what? 75. If this is, you divide. So let's see if these coordinates are there. So the first one is 0, 50. 0, 50 is this point here. Then the second one is 75, 0. Now, I think this is just there to guide us, so that, of course, we do not have 75 here. But let's say, if this is 60, our 70 is at this point. So where do we have 75? 1, 2, 3, 4, 5. So 75 will be here. So this point can guide us here. Okay? This point can guide us because this is just there to guide. So I'm going to say from this point, okay, from this point here up to like this. So then we draw a straight line, this one, okay. Then take note that in terms of an inequality, it's greater than, okay, it's greater than here. So the region that we're supposed to shade is this one that is below. We shade the region that is below here, okay. So you realize that we're going to remain with this region here. This is the region that we want, where we have said, where we put our R. This is the region that we want, okay. So we can move on to the next question. So C, Roman numeral 1 says, the profit on a dress is 160 kwacha and on a suit is 270. Find the number of dresses and suits the tailor must make for maximum profit. So this is what we're supposed to do. We write, first of all, we have our C A or C Roman numeral 1, profit. Okay, profit here, what did we get? On each dress, which is X, it's 160, plus on each suit, it's 270. That is the profit function. So from there, we're going to come and get these coordinates here, these coordinates on these parts. Okay, we start with these ones, these coordinates in the corners of this region that we want. So there's this one here, which is what? This is 30, 30. We're going to say 30, 30 here. Then I come to the second one, which is 50, 50. This is also 50, 50. Then the other one is 50, 50, this is 11, this is 12, 13, 14, 15, 16, 11, 12, 13, 14, 15, 16. 11, 12, 13, 14, 15, 16, 17. Okay, so this is 17. So we're going to say 50, 17. So you are going to have 50, 17. Okay, 50, 17. So now we need to begin slotting these ones here in the profit function. Like 160, where there's X, we put what? 30 plus 270 where there is y here. We're supposed to have y. Where there is y, we put 30. Then what are we going to get? We do the same thing even here. Let's finish the process. Okay, so when you finish your process nicely, these are the values that you're going to get, or these are the amounts that you're going to get. This is money, okay, in kwacha, Zambian kwacha. So these are the figures that you're going to get here. So now to answer this question, find the number of dresses and suits that Metera must make to maximize profit. You look at which one is the highest. The highest is 21,500. So which combination gave us this one? It's 50,50. So it means for this teller to maximize profit, the dresses should be 50. And then also the suits must be 50 from this combination that gave us the highest amount. Remember, this is X, which is dress. This is Y, which is suit. Okay? Then the last question is calculate this maximum profit. This maximum profit, what is this maximum profit? This maximum profit is this same one that we got here, the highest amount, 21,500. This one. That's what you are supposed to get here. And these are the answers to this question. Okay? These are the answers to this question. So we can move on to question 10. Okay, so we come to question 10. Answer the whole of this question on a sheet of graph paper. Use a scale of 1 centimeter. Okay? So use a scale of 1 centimeter. So this is 2 centimeters here. So 1 centimeter meaning half of this. Half of this, that is 1 centimeter. Okay? To represent one unit on both axes, draw x and y axis for the x, it should be from -8 up to 12. Then for the y, it should be from -6, from -6 up to 14. Okay, that's what we're supposed to have. So, okay. A. Draw and label triangle X with vertices 2, 2. Okay, 2, 2. Okay, so this is what we're going to have. Okay, that's what we're going to have. So now let's start plotting. 2, 2. I mean 2, 4. 2, 4 is this point here. Then 4, 4. 4, 4, this point here. Okay. Then 4, 1. 4, 1. 1, 2, 3, 4. This point here. Okay. This is the 4, 1. So we join these points. Let's join so that we form a triangle. So this is a triangle that we're going to have. Okay. It's a triangle that we're going to have. Then we move on to the next question that says triangle X is mapped onto triangle U with vertices 6, 12, 6, 12, 6, 12. Okay, this point here. Then 12, 12, this point here. Then 12, 3, 12, 1, 2, 3, 4, 5, 12, 3. So we also join these 3 points here so that we form triangle. Okay, join these 3 points here. Okay, how is it going? This is what we're going to have. Okay, so draw and label triangle U. So this is triangle U. Take note that the first one is what? Triangle X. Okay, so now the question says describe fully this transformation. So as you can see, this to this is an enlargement, isn't it? That's an enlargement. So to state an enlargement, we need the center of enlargement and the scale factor. So to find the center of enlargement, we join these 2 points, corresponding points, join this like this. Then we also find another pair. If it is this one, you can also use this one. So have you seen where these 2 lines have met? They've met at the point here. So we are going to say this is question 10, isn't it? Question 10 B2. This is an enlargement. Okay. Then scale factor, okay. And center of enlargement is 0,0, or the origin. Then the scale factor, what are we supposed to do? You can pick one side, that is, for instance, from this point up to this one, we can look at this. What is this? Okay. Or we can pick this side that is properly done. So from here we have, this is from 6 up to 12, isn't it? From 6 up to 12. So what are we getting here? This is 6 from this point up to this one. This is 6. So 6 has to be divided by this part here, which is 2. So what are we going to get? This is going to give us what? 3. Okay? This is what is going to give us 3. So you say 6 divided by, so we're going to have 3 here. 3 is our scale factor. Take note of that. Then we move on to the next question. This question says, 90 degrees clockwise rotation about the origin maps triangle X onto triangle W. Draw and label triangle W. Okay, so what are we supposed to do? This triangle has been mapped onto another triangle and in a clockwise direction. Then the origin here is the center of rotation. So what are we supposed to do here? All we are supposed to do is to pick, for instance, this point here. Where is it going to be? Where is it going to be? Okay, on the image. So we're going to join this point. You join these points up to the center. So in this case, I'm going to use this same line that is already there. Then after that, I'll now do this. I'm now going to do this. I'll put, this is 90 degrees rotation. Okay. So then 90, as you can see, our 90 is here. This is where our 90 is going to be. Okay. I'm sure you've seen. Then now I'm going to measure the distance. What is the distance from this point? So I'm starting from 1. So this is 5 here. Okay. Okay, so I'm measuring from 1. So from 1, this goes up to 5. Okay. This is because my ruler is broken if I started from. So even here, I will do the same thing. From 1, I need to go up to 5. So you will discover that it will come here. 1, 2, 3, 4, 5. It will come here. This point, it will be here. Okay? This point, it will be here. Alright? Then, let's pick another point now. This one. Let me join this one. Let me join like this. So, let's find the point. Again, I'll be using my protractor. From here, I need to measure 90. Where is my 90? My 90 is at this point. Okay. Then now I need to get the distance. The distance, what's the distance? I said I'm starting from 1. From 1, this is like 6.5. So again, from here, we say from here, we are coming to 6.5. So our 6.5 will be here. Okay, so now this point, it is this one. This point, it's this one here. So we definitely know that this one, I can, you can conclude where this one is going to be here. To definitely be at this point here, isn't it? Definitely be at this point. So this is where this triangle is going to be. You can do this. Okay, this is where this triangle is going to be. So meaning this is triangle what now? Triangle W. Okay, then we have a shear with x-axis as the invariant line. Okay, x-axis as the invariant line, that's good. And the shear factor -2 maps triangle X onto triangle S. Draw and label triangle S. Okay, so now you should take note that the coordinates here, that will be the coordinates that will be. Okay, so what we are supposed to do in this case now, since we are told that we're dealing with shear and the invariant line is this one. Okay, now shear, we are saying the points will move parallel to the invariant line. Parallel, isn't it? Parallel in this case. Okay, so when we look at, let's start with this point here. What is the distance from this point up to this one? What is the distance from here up to this one? It's 1, isn't it? So this 1, then we need to multiply it by what? By -2, which is the shear factor. So when you multiply it by -2, we need to move now 2 steps going to the left side. So we are going to come to this point here. Okay, which is this point here. It has been moved to this one. Then I'll come to this one. What is the distance from the invariant line up to this point? You can check, it is 4. So I'll move this point from here. This is 4. So this 4 now, you need to multiply it by -2. When you multiply it by -2, you get -8. So from this point, we need to go this side to the left 8 steps. Because we are saying this is 4, then you multiply it by -2. So this is 2, 4, 6, and 8. So it will come here. Then this other one also, it is 4 from here. So you also move it 8 steps going to the left from here. So it will be 4, 6, so it will come here. Okay. So this is how it is going to appear. So we can join now these lines here. You join. Okay. You join this one like this. Join them like this. Okay. Join them like this. That's what we're going to have there. Okay. So this will be the coordinate for, this is what our S is going to be. Okay. That's what our S is going to be. Then we have another question here, which is triangle X is mapped onto triangle M with the vertices. Okay, so let's plot these vertices. 4,4 is this same point here. 8,4 is this point here. Then 8,1 is this point. So you join. What are you going to have? It's going to give you this point as well as this one here. So this is our M. Okay, this is our M. And the question here now, there's another question that says find the matrix which represents this transformation. Find the matrix which represents this transformation. So what are we supposed to do in this case? So there's a matrix here. The matrix that we want is A, B, C, D, for instance. Then we get now the matrix for X, which was mapped onto this one. So this is going to give us the matrix for X. The coordinates for X, we have 2, 4, 4, 4, 4, 1. And then this gave us what? These coordinates here. What coordinates did we get? 4, 4, 8, 4, 8, 1. Okay. Then we try to form two pairs of matrices that will help us to solve simultaneous. Like for instance, this is 2A plus 4D, 4B, this is B here, 4B, this must be equal to 4. Now we can come to another one, which is 4A plus 4B is equals to 8. Okay, so these two matrices will help us to find. We are using this one and this one, then equate to this one. This and this one equate to this one. So we can also do the same for the second one. C multiplied by, this will be 2C plus 4D is equals to this 4 now. Okay, then 4C plus 4D is equals to, again, 4. So we solve these simultaneously. I'm sure you know how to solve simultaneous equation. So we can eliminate here. When you use the elimination method, you have 2A. You have negative 2A is equals to negative 4 here. Okay. So you divide A is equals to 2. Okay. So then if A is equals to 2, when you put A here, this will be 4. Then when you take it to the other side, you have like 2 plus 4B is equals to 4. So this is going to be 4B is equals to 4 minus 4, which will be 0. So B is equals to 0. B is equals to 0. A is equals to 2. Again, these ones, you use the same method. So when you subtract here, you have minus 2. This is going to give you 0, 0. So that is C. Remember, we are dealing with C here, sorry. So C will be equals to 0. Okay, C will be equals to 0. So what will be our D? Meaning, where there is C here, you put 0 plus 4. D is equals to 4. So this is 0 is equals to plus 4D is equals to 4. So D is equals to 1. D is equals to 1. So remember, our matrix is what? A, B, C, D. What is our A? Our A, we found 2. What is our B? Our B, we found 0. Our C, we found 0. And our D is 1. So this is the matrix here that we want. Oh, sorry. Our C is what? C is 0. So this is the matrix that we need here. Okay? This is the matrix that we need. So we go to the next question. Question 11. So question 11 reads, a farmer planted 60 fruit trees. In a certain month, the number of fruits per tree was recorded and the results were as shown in the table below. Okay, so we have seen the table here. We've seen the table here. So this is like one tree, 2 fruits, about 5 trees. Each one of them had 3 fruits. That's the understanding here. Then calculate the standard deviation. So in this case, this is grouped data. This is grouped data. So in this case, we need to come up with a simple table here, which has got X, F, which is our frequency, and the Fx and Fx squared. We have reduced the number of columns, don't worry. So our x, for instance, take note. Our x, for instance, is what? Is 2. Then what is our frequency? It is 1. Okay? The second one, what is our f? Our f is, our x, sorry, it's 3. What is our frequency? Our frequency is 5. That is our frequency, okay? Okay, now look at this. This is f multiplied by x. What is our f? Our f is 1, okay? Our f is 1. So 1 multiplied by 2, we're going to get 2 here. This is the same thing. What is our f? Our f is 5 multiplied by x, we get 15. Then here we want f, which is this part. F multiplied by x squared. F, which is 1 multiplied by x squared. What is our x squared? X is 4. When you, is 2. When you square this one, it will become 4. So 4 multiplied by 1, what do you get? You're going to get 4. Then here we do the same thing. 5, let me show you. 5, which is our f, multiplied by x squared. What is our x? Our x is 3. So you say 3 squared. What do you get? 45. You go on and on like that until here you get the summation of this part. You also get the summation of this part and the summation of this one. These are the ones that we want, these. Okay? So go on and finish this process. Okay? And when you finish this process, you should be able to get your answers. Okay? When you finish this process, you should be able to come up with this table. A table like this one. Table like this one. Okay? And these will be your totals. These are what will be your totals. Now, you should know that we need to find x bar before we go to standard deviation. So x bar is summation of fx divided by summation of f. So this is the summation of f, and this is summation of fx, and this is summation of fx squared, because we are looking at where they are coming from. Okay, then this is now equals to 379 divided by 60. 379 divided by 60. I'm going to write everything. 6.316666667. Okay. Then now after this one we come to standard deviation. Standard deviation, we are using the formula over minus x bar squared. So standard deviation is equals to, what do we have here? It's 2559 over 60 minus 6.316666667 squared, close brackets, open brackets and close. Okay, so this is what we are going to do here. So we open brackets, you first put the root, then open brackets, divide 2559 divided by 60 minus what do we have there? Sorry, 6.3166666, okay, and 7 squared, close brackets. What are we going to get? Okay, this is what we are going to get, isn't it? This is what we are going to get as our standard deviation, which will be 1.65. Okay, 3 significant figures. Okay, 3 significant figures. This is what we're going to get. All right, so let's go to the other part here. This other part, this other part here. Okay, let's look at this other part. B, answer this whole part of the question on a sheet of graph paper. Okay, so what are we supposed to do now? So you copy this part, copy this on the graph paper. Okay, you copy this on the graph paper, and I'm going to show you how you are supposed to complete it. You copy this on the graph paper, and I'm going to show you how you are supposed to complete it. So okay, so when you copy this table, you need to copy it right on top of your graph paper here. Okay, that's where you are supposed to put it. Then to complete it, take note, it has got 3 rows here. So we are dealing with the relative cumulative frequency. So to complete the last 3 parts, you need to use this one. 60 is what you are using. So to get the part for this one, you say 26. Okay, you say 26 divided by 60. What do you get? You're going to get 4.3, isn't it? So 0.433. Okay, so take note. Then when we come to this one, you say 42 divided by 60. This will be 0.7. I'm sure the last one, you know, it will be 60 divided by 60, so it will be 1. But you're supposed to copy this table right on top of your graph paper here. Okay, then now you begin to plot. Now when you are plotting, take note, here we're dealing with a relative cumulative frequency. The middle part, we don't use it. The middle part, we do not use the middle part. We don't use the middle part. Okay, we don't use the middle part. So we're going to deal with what? We're going to deal with the one. We're going to deal with the, when we are plotting, we'll be dealing with the first ones and the last ones. Okay, so here we're told using a scale of 1 centimeter to represent 1 unit on the x-axis from 0 up to 8, and 2 centimeters to represent 0.1 unit on the y-axis from 0 up to 1. Draw a smoothie. Okay, so this is what we are supposed to do, like I have done it here. Then we go up like this. So we can begin to plot here. So the first one is 2, 0.02. Okay, so start from here. 2, 0.02, so it's this point. Then 3, 0.1. This one. Then 4, 0.17. 0.17. It's 1, 2, 3, 4, 5, 6, 7. So it's this point here. Then 5, 2.27. So 5, 1, 2, 3, 4, 5, 6, 7. Then 6, this one now. 0.43. 6, 0.43, this point. And 7, 0.7. 7, 0.7. 7, 0.7. So we have 7, 0.7, 1, 2, 3, 4, 5. This point here. Okay, then 8, 1. 8, 1. 8, 1, which is this point. Okay, so then we need to join these points now nicely. We can join them from any point. Okay, like this. Okay, So this is the relative cumulative frequency. This one is the relative cumulative frequency. Then now here we are told that showing your method clearly. Okay, so what we are supposed to do here now, clearly showing your method clearly, use your graph to estimate the 70th percentile. So we are going to say 70 over 100 multiplied by, what is the total here? Relative cumulative is 1. Okay, so when you multiply this, you're going to get 0.7. So you come to 0.7 here. Where do you have 0.7? 0.7 is along this, then you get to the graph here. Then this line that drops down here, you follow it nicely. You follow it nicely. Or if you want, you can actually put a ruler or paper so that you don't lose your what? So it will come direct to 7. It will come direct to what? To 7 here. Okay? It's going to come directly to 7. So we are saying question 11B, Roman numeral, the 70th percentile here is equals to what? 7. Is equals to 7. Now you should take note that here it's like we're talking about fruits per tree here. Okay, this is like fruits per tree. So that 7 represents the number of fruits. Okay, so we go to the next question. Okay, so we have the first question here that is talking about express, okay, these two fractions as a single fraction in its lowest terms. So the first thing that we're supposed to do here is to find the common denominator, which will be the same one, the same these two. Okay, then when this one, when this is divided into these two, this and this will cancel, so we're going to remain with this one. Okay, the same will be the case when this one is divided into we'll remain with 2x minus 5. Then we try to break down to simplify the top part. So 3x minus 9 minus 8x plus 15. So this is going to give us 3. Remember, we keep the denominator. Then here we have what? When you simplify 3x minus 8x, what do you get? This is going to give you what? Minus 5x plus, what do you get? Okay, this, what do you get here? What do you get? All right. Okay, take note, this is 20 here. Okay, this one is 20. Then so minus 9 plus 20, this will give us 11 over 2 x minus 5 x minus 3. This is what will be our answer here. Okay, okay, then B, the diagram below shows the graph of y is equals to x cubed plus x squared minus 12x. So this is the graph. Okay, then use the graph to solve the equations. So this one, the first one, look at this. Where there is y here, we have a 0. So where is y is equals to 0 here? It's along the x-axis, isn't it? It's along the what? The x-axis. So we're going to be getting these coordinates here. Y is 0 here. So here we have x is equals to negative 4, comma, what is the other one? Also here, x is equals to 0, and the last one, x is equals to 3. So you have this one, and this one. These will be your answers here. Negative 4, 0, and 3. Then this one. So meaning, here y is equals to what? X plus 10. So we need to find this equation here. Y is equals to x plus 10. So we need to say, we need to use these coordinates here. For instance, I can take x and y. I can pick the first one and the last one. When x is equals to -4, here, when you put -4 here, what do you get? This will be 6. Okay? Then what about when x is equals to 4? This will be 14. Okay? This will be 14. So we can use these 2 points, -4, 6. Where do we have this point? 1, 2, 3, 4, 5, 6. We have this point here. And then 4, 14. 14. 1, 2, 3, 4. This point. So we can join these 2 points now. Let's join them with a ruler. You join them like this. I'm sure you've seen the line here. So then we come and get the x coordinates where the two are crossing, here and this point. So the first point here that we have, okay, the one point that we have here is what? It's -3, -3.7. So here we have one of them is x is equals to -3.7. Then the other one is what? -0.7, -0.7. Then the last one is 3.1234. The last one is x is equals to 3.4. Okay, so these are the equations. These are the coordinates here. Okay, then this part, calculate an estimate of the gradient of the curve at the point where x is equals to. So the best that you do here is to find dy dx of this one. What is dy dx? This will be 3x squared plus 2x minus 12. Then now we say where there is x, we put now -3. So what are we supposed to do? This is going to be -3 squared. Of course, this because of the minus and this, it will be -6, 12. So this is going to be what? 27 minus 18. What do you get here? Okay. What do you get? Okay, so this gradient is going to be 9. Okay, that's our gradient. Let's do the last one. So we are calculating an estimate of the area bounded by the curve, and the x is equals to -3. Okay, then x is equals to -1. X is equals to -1. X is equals to -3 is here. Okay, and then x is equals to -1 is here, then 10. Okay, so we can, how do we find now the area of this? I'm sure you have seen the region that we're talking about. Okay, 3 here, 1 here, and then this one. So we can even cut this part. Okay, let me cut this part so that we have this triangle here. Okay, so we have formed this part here from this point up to this one and this one and this one. So here we can try to, which is like this. Okay, So we are saying from this point up to this one, what do we have here? This is 2. Then going up from this point up to this one, so this is 10, this is 20, and 22. So it's like this is 22 here, okay? Then we have another part that I've crafted here, which is this side. This is 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's take it that this is 8 here. Then here it's 1. Okay, then the triangle, this is 1. This part is also 1. Then up it's 8. So when we find now here, this is going to give us what? 44 when you multiply. And this one will give us 8. Then this other one will give us, of course, so this will give us 4. So we need to add 44 plus 8 and that. This will give us what? 12, huh? So this will be able to give us 56. Okay, so 56 unit squared is what we are going to get here for the last part. Okay, thank you very much for watching. Please don't forget to subscribe. Okay, goodbye until next time.